Trigonometry is what we're going to start today. So starting with trigonometry, we're going to talk about some basic things. So when we talk about angles, you're supposed to be using uppercase letters. So when you talk about an angle, uppercase letter. And when you talk about a side, then it would be a lowercase letter. So that's a basic property. Maybe we know this from the past. How many degrees are inside a triangle if you could add up all the corners? 180 degrees. So that's a property we should have memorized. And the letters given to the sides are always located across from their angle. So what does that mean? If this is angle Z, then this is side Z. That's across from it. So if this is angle Y, then this is side Y. Okay, so those are just some basic properties that will carry throughout the whole unit and then next year. Okay, so lesson 1 is going to have us dealing with similar triangles. So similar triangles means that there's two triangles that are proportional. And you know what I always think of is on a Word document when I have a picture and then I drag it, enlarge it, or shrink it. Okay, that's kind of what's happening. Okay, so what I'm going to do is this. I'm going to put a square around the 5 because it's across from the square angle. I'm going to put a circle around the X because it's across from the circle side. And I'm going to put a star around the 7. Can you do the same feature on the other triangle? Give me which side would be the one that connects to the square, the circle, and the triangle. So if you can kind of see it, this is called the little one, this is the big one. It's like you enlarged it and then you kind of flipped it over, but they are similar to each other. Okay, so we're going to make proportions. So probably you've done this somewhere in your math career. Okay, so I'm going to go the little square to the big square. The little square to the big square should be the same ratio as the little circle to the big circle. So that would be an X on the little circle and a 12 on the big circle. Okay, I'm going to have a candy up for grabs here. Who can think of something? Okay, I want to solve this proportion using a math strategy. Does anybody know the name of the math strategy you could use to solve when you have two proportions like that?
Cross multiply?
Yes. That's Isaiah, right?
Yeah.
Cross multiply is the answer. So how does cross multiplication work? You multiply two diagonals. So that would be that. You multiply and then you divide by the lonely one. Multiply across, divide by the third item. So now that you've heard the word, do you remember doing that somewhere in your math? So 5 times 12 divided by 9 means x would be 6.67. Does that kind of visually make sense, that number? Yeah. Okay, I'm going to do the same thing, except for I'm going to do it with the stars. Okay, so the little square to the big square, and I'm always using those because those are the two numbers that I can match. Little square to big square will be the same as little star to big star. You notice how I'm always lining them up little to big, little to big? Okay, and then I'm going to use the same strategy, which is that cross multiplication. So what two items should I multiply? 9 and 7, which means the divider would be the 5. So 9 times 7 divided by 5. Oh, I left room right below. That's nice. So there's what I did. So I should have just put those in there, but that's okay. Did you guys put yours in the boxes? Nope, you didn't realize that either. Okay. So number 2, I want you to label. So for instance, 21 would get a square around it. And x would get a circle. And the 12 and the 4 would match up. They obviously, would you agree that this angle, I'm going to use a cloud, these two angles would be the same? Okay, when you crisscross lines, the diagonals, these angles are the same. So what does this mean? This angle is the same as this angle. This angle is the same as that. This angle is the same as that. That's what this is meaning. Okay, you can see it here. This circle is the same as that circle. The star and this star are the exact same numbers. So the angles in them are all the same. Okay, so which two am I going to use? I'm going to pair 12 and 4 because those are two numbers. So the big cloud to the little cloud will be the same ratio as the big square to the little square. Times and divide. You can do that as well. Yeah. If you did 4 over 12, then you would have had to do y over 21. As long as you have it lined up, it will also work. Yeah, so that's a good question. Could I have done 4 over 12? Yeah, you could totally do 4 over 12, but if you do that, then you also have to do y over 21. You have to make sure you're lining up. I always call it like t-shirts and pants. Put on your t-shirts and pants the same way. Okay, so if I jump to the circles, I'm going to still use big cloud to little cloud, and then big circle to little circle. And again, if you had had the 4 over the 12, then this would have had to be a 6 over x. It would have all had to be upside down, and that works too. So you're going to multiply diagonals, divide by lonely. Okay, and the last one of these. Okay, sometimes people look at this and it's hard to visualize because there's a triangle inside a triangle. So really, you can think of them separately. Okay, so what do I know about the small triangle? I know that's a 5 and that's an x. What do I know about the big triangle? Bless you. The bottom is 12. What is the length of the big triangle here, though? 21 plus x. Good. Okay, it's not 21. That's not the triangle side. It's 21 plus x. Okay, so let's set up a ratio using those. The big bottom to the little bottom, the ratio of the big bottom to the little bottom is the same ratio as the big diagonal to the little diagonal. Does that make sense how we set up? Big bottom to little bottom is the same as the big diagonal to the little diagonal. Okay, so we are going to, again, use cross multiplication, but this time it's a little different because we have variables in both parts. So we're going to go this diagonal equals this diagonal. So this diagonal is going to be 12x. That diagonal equals this diagonal. So this diagonal would be 5 times. So there's going to have to be some distribution involved in that diagonal. So you have to do 5 times that set. So 21 times 5 is 105. And how do we work to solve this? What would be a good algebra maneuver here? Bring the x's to one side. So I'm going to do a minus 5x. Okay, so we're going to quickly do Pythagorean theorem as well today. So I think you've seen this formula somewhere, correct me? Yes, somewhere you've done it. Okay, so when you use Pythagorean theorem, you can only ever use it in a right triangle. Because once you get into grade 11 and 12, you don't study right triangles anymore. And you can't use it unless it's a right triangle. In a right triangle, the side across from the 90-degree angle is always the hypotenuse. What else is that side always going to be? The longest. Okay, so here's the formula. A squared plus b squared equals c squared. And in that formula, the C is always the hypotenuse. And the A and the B are always the other sides, and it really doesn't matter. Okay, so how does it work? So on this one, I want to find the hypotenuse. So I would add 5 squared plus 12 squared. So I would jump into my calculator. 5 squared plus 12 squared. If you don't know where your squared button is, please call me over at some point and we can figure that out. Equals 169. So that's not the length. What is the math that I would still have to do with that number? I would have to square root it. And you know what I'm going to do? I'm going to go like this, square root, and I'm going to push the answer button. I don't ever want to retype something in. Do you see an answer button on your calculator? If you don't, I'm going to come around after this and we're going to find it because it's going to change your life using that thing. Because in grade 11 and grade 12, you can't do any rounding. You want to use that. And then I got 13 on it. Okay, so on question 2, this is an other side. I'm just going to call it another side. It's not the hypotenuse, right? So if I want to find the other side, I'm actually going to subtract because I'm getting one of the smaller sides. So this is what I want you to type in. So 17 squared minus 8 squared. Then I want you to go the square root and push the answer button again. By the way, if you forget to square root and you wrote 225, you should look at that triangle and say, that seems ridiculous as an answer, right? You're always saying, does my answer make sense? Well, that wouldn't. Okay, question 3. You're going to tell me, should I do a Pythagorean add or a subtract? A subtract, because you are not finding the longest side. So this one comes into a decimal. Are you getting a decimal part? So I want you to write that to 2 decimal places. So you're going to have to do some rounding. So 18 point what? 1, 4. So yeah, when it's not a nice number, go to just 2 decimal places on it then. Okay, so we're just going to conclude here on the next page. So basically, if you're going to find the longest side, you would do an add. And if you're going to find one of the shorter sides, you're going to be doing some kind of subtraction. Okay, so that's how it's going to work. You either are picking if I'm adding to get to the longest or subtracting to get to the shorter.